Welcome, learner, to our today's discussion. We are going to discuss a topic called radioactivity. Radioactivity is a topic in chemistry book 4. Now, before we even discuss it, it's good enough to ensure that we go through the objectives, or rather, what is the learner supposed to have understood by the time we are through with our discussion. One, the learner should be able to define the term radioactivity, define the term half-life, radioisotopes, and nuclides. By the time we are through with our discussion, the learner should be comfortably be able to define those terms. The second objective that the learner should be able to meet by the end of this discussion is that the learner should be able to state the types of radioactivity, name the particles emitted during the radioactive decay, and state their properties. The third objective is that the learner should be able to carry out simple calculations involving half-life. And the fourth one, that the learner should be able to write balanced nuclear equations. The learner should be able to write balanced nuclear equations. And the fifth objective is that the learner should be able to differentiate between nuclear fusion and nuclear fission. These are two terms that the learner should be able to differentiate by the time we end our discussion on radioactivity. And the last objective that the learner should be able to meet is that the learner should be able to state the uses of radioisotopes, and the dangers associated with radioactivity. Those are the objectives that the learner should be able to meet by the time we are through with our discussion on radioactivity. Now, to start off, I would like us to review whatever you covered in chemistry book 2 about the structure of the atom, So let us review whatever you did in book 2. In book 2, you studied about the structure of the atom, and reactions involving valence electrons, and reactions involving valence electrons. Now, the key word here that I've underlined is the word valence electrons. Now, I would like us to go back and remind ourselves, what are valence electrons? Remember, if I'm going to use an example, let me use an example of an atom. And this atom I'm going to use is lithium atom. Let me use lithium atom. Now, lithium is in atomic number 3. And its electronic configuration is 2,1. If I was to draw this structure, then I would come and ensure that I've shown the nucleus, lithium. Then the first energy level is going to be occupied by 2 electrons, 1, 2, and the last energy level, and the second one and the last energy level is going to be occupied by 1 electron. Now, the 1 electron in the outermost energy level is what is called a valence electron. So this is called a valence electron. Now, in Form 2, you studied that for a reaction to occur, this lithium must lose 1 electron. It is going to lose the 1 electron, which is a valence electron. That type of reaction is called a chemical reaction. Therefore, you say that a chemical reaction involves valence electrons. And learner, you can be able now to come up with different atoms and be able to identify what are the valence electrons. For instance, if you talk about another atom like chlorine atom is in atomic number 17. Therefore, its electronic configuration is 287. Remember, there are 7 electrons in the outermost energy level. However, for chlorine to react or to form a chemical bond with another atom, chlorine requires to gain 1 electron. To become stable, or to attain a stable electronic configuration, to attain an octet. stable electronic configuration. It's going to gain 1 electron. So the 1 electron that chlorine is going to gain is called valence electron. It's called a valence electron. Therefore, we can simply define valence electron as the number of electrons that an element requires to either lose or gain to form an ion or to attain a stable electronic configuration. That is called a valence electron. And valence electrons is what are involved in chemical reactions. That is something you covered in chemistry book 2. Now going forward, in radioactivity, we are going to talk about reactions originating from the nucleus. We're going to talk about reactions originating from the nucleus. Reactions originating from the nucleus. Now, if I am to just draw a general atom, I'll have this region. This is the region that's occupied by electrons, where we have our different energy levels. Region occupied by electrons, and we are saying that this is where chemical reactions take place. Now, for our discussion on radioactivity, we are going to talk about reactions originating from the nucleus. And learner, you can be able to identify that in the nucleus we have both protons and neutrons. Those two are what are found in the nucleus, and therefore reactions originating from the nucleus involve both protons and neutrons. Such kind of reactions are called nuclear reactions. And therefore, our discussion throughout this topic is about nuclear reactions, what we shall be talking about on this particular topic. Now, having explained that, I would like us now to look at the stability of isotopes of elements. Stability of isotopes of elements. Now, when we talk about stability of isotopes, there is a term that has been introduced here, a term that you came across in chemistry book 2, isotopes. But before we come to isotopes, I would like us to define a term called nuclide. I would like us to understand what is nuclide. Now, a particular nucleus characterized by its protons and neutrons is called a nuclide. A particular nucleus characterized by its protons and neutrons, is called a nuclide. So when we talk about a nuclide, you're talking about a nucleus which shows both the number of protons and the number of neutrons. In other words, we are saying that a nuclide will show the mass number. A nuclide will show the mass number and the atomic number of that particular nucleus. So, for example, look at chlorine 3517 and chlorine 3717. What you can see here, we have defined nuclide as a particular nucleus characterized by its protons and neutrons. From this specific nuclide, we can be able to see the mass number and the atomic number. Atomic number is the number of protons in the nucleus of an atom. Therefore, 17 is the number of protons in this particular nuclide. But then we are talking about protons and neutrons. How are we going to get protons? Something that you did in chemistry book 2. Since this is our mass number, that 5 is our mass number, and you know very well that mass number is the same as the number of protons, is the sum of the number of protons, and number of neutrons. And since from this particular nuclide, we already know that it is in atomic number 17, and therefore it has got 17 protons plus neutrons. We don't know how many they are. But mass number here is 35. Therefore, we can simply get our number of neutrons to be 35 minus 17, which is 18. Therefore, this particular nucleus has been described in terms of both protons and neutrons, because we can simply get neutrons from mass number. Whereas for this particular one, this is now for chlorine that 5 has got 17 protons and 18 neutrons. For chlorine that 7, we can be able to get it has got 17 protons, can you tell that? 17 protons, and has got 20 neutrons. Since it is that 7 minus 17 has got 20 neutrons. So, learner, that is what we call, that's how we define the term nuclide. Any nucleus, but its description is in terms of both atomic number and mass number. And from mass number, we are able to get the number of neutrons. That is a nuclide. That's what you call a nuclide. Now, proceeding from there, now many elements have got nuclides with the same atomic number but different mass numbers. So many elements, and you've seen this one in chlorine that 5, 17, chlorine that 5, 17, and chlorine that 7, 17. So this is an element called chlorine. Have got nuclides with the same atomic number. These are two nuclides with the same atomic number but different mass numbers. These type of nuclides are called isotopes. So we can say that atoms of the same element with different mass numbers are called isotopes. And a good example is that one of chlorine. They have got the same atomic number but different mass number. These are called isotopes. And you come to realize that some isotopes are more abundant than others. When I say more abundant than others, what do I mean? Take for instance, naturally occurring chlorine. Obviously, you expect that naturally occurring chlorine has got the two isotopes, chlorine that 5 and chlorine that 7. But you find that chlorine that 5, by mass, you would find that the isotope chlorine that 5 occupies 75% by mass. You can also say by weight. 75% by mass of the naturally occurring chlorine. While chlorine that 7 only occupies 75%. Chlorine that 7 only occupies 25% of the naturally occurring chlorine.